And we're back! Now, in case you're new, this rusty little car has had a heck of a lot done to it over the last number of years, but conveniently, it's all summarized in this video here, which you should really check out. The rest of you may remember that the last episode focused on building some new engine and suspension mounts, and we've got a lot more fun times scheduled for today. But have I ever steered you wrong? If you haven't yet, subscribe and hit the bell. We've gradually worked through a ton of geometrical challenges up here, but thankfully the steering rack will complete the puzzle by taking care of these final 2 points. So, how hard can that be? Well, I hate to complicate things right from the start, but, well, here we go. Yeah, the rack will take care of those points, but that's not really the right way of looking at this. It's actually the inner tie rods that define the points, and the rack simply needs to accommodate them. So let's start there then. Bearing in mind the outer tie rod positions were investigated in episode 16 and all as well. Where these are located will dictate whether or not we have any bump steer, which is just as it sounds. You hit a bump and the tire steers itself. Effects are not exactly what one would call ideal. So I sense some more geometry incoming. Oh, you betcha, bud. As with the upper and lower control arms, the tie rod assembly also pivots through a range of motion, sweeping an arc. Unlike those other components, though, it also moves, which just makes everything a little more interesting. None of these parts are the same length, but even so, to ensure there is no bump steer, all of them need to work together. To find this location, then, let's draw a line through the ball joints, as well as the control arm mounts. Yes, there are actually 4 mounts in reality, but for the sake of this video, we're just going to keep it simple and use the front 2. Another couple of lines need to be added, this time through each control arm, and they should meet somewhere over here at an imaginary point known as the instant center. As you may have guessed, the tie rod assembly needs to point here, and with that final line in place, you get one more intersection point here, which is precisely the location we're looking for. This should be calculated with a lot of messing around in math, but who's got time for that? Short of Jason Fensky, I guess. Anyway, instead we're going to take a trial and error approach, as knowing what to look for is half the battle. If this point was any lower or further out than this design, we would get toe in under bump, and likewise, any higher or further in, toe out. Consider it magic. And like any good magic trick, it's likely to fail if you don't follow the guidelines that have been laid out for you. Speaking of not following guidelines, unless you're Picasso, we do actually exist in 3 dimensions. So let's also take a look from above. A good rule here is to keep things in line, as if the rack is fore or aft of the steering arm on the knuckle, you do risk messing up Ackerman and or reintroducing some bump steer during turning. You can get away with small movements, but let's try to get as close to perfect as possible. With that all out of the way then, let's get on with it. Months ago, we had the foresight to keep the original GT6 rack, since for perhaps obvious reasons it seemed like the logical choice. But thanks to our new geometry, it's now massive. Sadly, even if we chose to modify it, to get anywhere close to the geometry we just talked about, the whole thing would have to be about a foot long from one inner tie rod to the other. And that's not going to work. It seems then, in order to get things small enough, we can't use the stock unit, so we'll have to buy a new one. The most likely candidates either being one with a travel bar, or perhaps a center takeoff unit. So after a lot of research, what we decided to do is use the stock unit. Hear me out. It just so happens that although this geometry is correct, in concept, it's missing one key element. The point on our knuckle isn't here. It's here. That means the inner tie rod also needs to move over by the same amount, and bippity boppity bacon, we've gained back some wiggle room. Now keep in mind this added distance is on both sides of the rack, and we've totaled a little over 2 inches. Agreeably, 50.8-ish millimeters is not exactly a lot, but it does increase our chance of making things work. And there's more. The steering arms on the new knuckles are a bit shorter than the original Triumph units. This smaller lever arm effectively gives us a faster steering ratio, or in other words, fewer turns are needed to go from lock to lock. Additionally, our
Maximum lock angle also needs to be reduced a bit, as otherwise our wider tires will rub in the wheel wells.
Both these factors mean we need to reduce the total travel in the rack, which is good.
You see, the factory setup needs almost 7 inches of travel to go from lock to lock, which means the body of the rack needs to be that amount shorter than the solid steel rod passing through the middle of it. The rack part of the rack. To fit our dimensions and maintain that travel, the body would be reduced to practically nothing. Therefore, the less travel we can get away with, the longer the body can be, and that will give us better strength plus a chance of mounting it.
One final benefit is we'll also have more direct steering, which should make the car feel modern, at the sacrifice of a heavier weight to the wheel. Probably a lot heavier when you consider everything we've done. So, I think I foresee some power assistance in our future.
Drawback notwithstanding, it looks like we've got a plan, so let's push on and quickly mock things up to see if it will fit and work as intended. The rack needs to clear the oil pan, provide a path for the steering shaft to meet up to it, and of course place the tie rods in the required locations, so this seems about as good as we're going to get. Note that we've pushed the rack back into the body a bit to simulate reduced travel, but even so, the position of the actual ball in the tie rod is still too far over here. Ideally, it would be here.
I think we've got a solution for this figured out, but while we wait for it to arrive, here are some brand new outer tie rods to give us something to aim for. And yes, the sway bar end link there is also new, but just ignore it.
Perhaps unsurprisingly, the factory Crown Vic tie rod is a very tight fit in our 15-inch wheels. There was one other option available from a late model Taurus, but it wouldn't have worked for other reasons, so we just said, send it! And luckily everything's fine. If in doubt, send it. You might just be able to tell that they're a little bit beefier than a stock GT6 part. With those in place, let's plop the rest of the clobber back in again, this time also sporting a very nice double universal joint, which will allow us to sneak the rack as far underneath the oil pan as possible. More fiddling around with the position was needed, and we're still just using the factory inner tie rods for visual aid at this point, because the real solution is this. Our very first Japanese part from a 1983 through 86 Toyota Camry. Note it has external threads for mounting to the rack rather than internal. This is key. It produces a tighter package, so with it attached to the outer tie rod on one end and this little jig on the other, it looks like we're pretty darn close to our target range. So let's see how it does. With the meter stick now clamped to the hub, we can measure out to it from the side of the frame, and note if anything changes as we articulate the suspension. At ride height, we've got just over 3/8 of an inch at the back and front, so we're nice and straight for starters. In compression, we've now got a hair over 5/8 at the front and darn near the exact same again at the back. So virtually no bump steer at all. Imagine that. Math works. Let's lastly take a look at it in droop. Just over 1/4 inch in the front and perhaps a hair less in the back. Still though, for the very first attempt at locating things, this is fantastic.
Honestly, we could fiddle around for ages to make it absolutely perfect, but it does become a matter of diminishing returns. And even if we're generous and round up the total difference to be 1/8 of an inch, which it's not, it would still mean we've got less than 0.6 degrees of maximum bump steer, so I'd say we're golden. By the way, if you're wondering why we just used a meter stick and told you the results in inches, you're obviously not a Canadian, eh?
Okay, I think that just about covers everything you could possibly want to know about this stuff. So, with it all considered, let's get some final measurements and start cutting. No going back now. Gosh, it's going to be a tiny unit. With the rest of the material removed, we did a quick mock-up with the bellows and solid aluminum mounts in place. Which, by the way, were both purchased years prior to the Restomod idea. It's all about keeping things original around here. Happy with things, it's now fused together, although sadly we forgot to hit record on the time-lapse camera, so can't show you how it was done. Just know, it was complicated and involved some angle iron and patience. With it in place down here, you can see how much room we've been able to leave for travel. It's honestly far better than we ever expected, and with a bit of cleanup, it's now shiny. And who doesn't like it when things are shiny? The rack itself is now also chopped down, which I thought would scare the heck out of me, but I guess we're getting pretty numb to this kind of thing. We made sure to align both of the mounts to ensure it will sit flat in the end, and on the whole, I gotta say it's pulled through its surgery rather well. Let's see if it still fits together. Of course it does. Although, it does look a bit like something taken from a go-kart at this point. A friend of ours, who happens to own a machine shop, helped us out by drilling and tapping some very precise threads in the rack. Thanks, Henry. We did give it a shot beforehand on a scrap piece, but just didn't trust our results, so we thought it safest to leave something like this to a professional. Note we are using the original jam nut to reinforce the area, create an end stop to prevent the rack bottoming out on the final tooth, and still fulfill the job of being a jam nut for the tie rod. The other end has received the same treatment. Naturally, though this side doesn't get a jam nut, as it doesn't really need it, and some medium strength thread lock will make sure nothing comes apart. We've ended up with just over 4 3/4 inches of maximum travel, which we're going to take up to an even 5 by trimming this area back a bit. This is way more travel than we were expecting to have initially, and by some mass should give us a turning circle of less than 30 feet, which is amazing. That takes care of the rack for the most part, so next up, let's build its mount. These are slotted, so that'll go in there like that. We then got some 1/4 inch plate that's going to go on the top, so that this remains flush from side to side, and it helps really beef up the area where we're then going to have the rack mounts attach. This is a U-bolt, so we're just going to have 2 holes drilled in here. The U-bolt will then slide down through it, bolt up from the bottom. That'll then hold the steering rack tube up like that, clamp it all down, 100% metal, no rubber. They will fit up against the front of the cradle like so, which is a pretty tidy solution, I must say, and almost feels like we thought this up months ago. We were trying to be smart and calculate everything beforehand so we could just cut it all and then bolt it together, but misjudged the location of this piece. It actually needs to be a little bit further back. So we're gonna have to take these apart, fill in these holes, make some new ones back further. With those misaligned slots magically filled back in, 1/4 inch plate fused in place, and mounting holes drilled, it's looking pretty snazzy. It would probably be fine just like this, but we prefer the idea of tying them together for a more robust package. Like that. Okay, that's looking pretty sweet, honestly. I'm quite proud of that. Things are square, everything's lined up evenly, and being completely metal should mean we will have all the road feedback. And if nothing else, it's definitely shiny. We've now just got it propped up with a piece of wood and that temporary jig, but I dare say it's going to work out. That sweet little double universal joint has really saved some headaches, and although it will need a standoff eventually, that shouldn't be too bad at least. Upon tightening things down though, we noticed a slight design flaw. Those solid aluminum clamps are holding the rack about 1/8 of an inch higher than we were expecting, and we're really not quite sure why. If we had an accurate way of machining off that 1/8 of an inch from the lower block, we'd just do that. But as we don't, let's just weld in some little strips of metal to take up the difference and fill the void. There. That's more like it. There's nothing left to do at this point other than tack it in place, so bam! There you go. It's just that easy. Like I said, it is just tacked for now, as we want to run everything through its paces before fully committing to this, but after a lot of fussing around, everything is looking good to go. So we've begun by setting this distance here at 2.5 inches, so that centers the shaft inside of the rack tube. We set this wheel to straight ahead. We measured the length of the inner to outer tie rod here and set the same over here, and then we measured from that flange to see if it was straight ahead. This wheel was slightly out, so we just kept fiddling around with actually shortening this and shortening that, an even amount side to side. Keep on straightening this wheel up again, which is actually moving the rack around at that point. We had an F-clamp helping to hold the rack up. And eventually we got to the point that this wheel was straight ahead, that wheel was straight ahead. We still had the 2.5 inches of stick out on that side, so the rack was centered. So that's where it needed to live. So we put some tacks on there now. Things are fitting reasonably well. We've got clearance all the way around
the U-joint so that it's not hitting the cradle and it's not hitting the oil pan. Everything is tight, but we're kind of used to that with this car. And what we're going to do now is I'm going to go inside the car. Dad's going to take the camera, and if I turn the steering shaft inside here, it should turn the wheels. We're going to try. So, is that turning wheel?
Yes, it is. And both of them, as a matter of fact.
Beautiful. Imagine that.
And there's the plan.
How much is that moving the wheel? Because that's about half a turn of rotation.
Enough.
Enough that you're going to notice at highway speeds.
Oh, yes. That's enough to change lanes at highway speed.
Oh, wow. Yeah, that's actually significant.
Yeah.
Well, that's brilliant.
Well done. Yes, thumbs up.
So that's it then. We knew it'd be fun, but then again, the joy of the build is most of the reason behind the project, so I'm not exactly complaining.
It's been quite the learning experience to get all the suspension geometry sorted out, and our heads are pretty tired from it, but we're at least sure that nothing is so terribly out of whack that the car will be undrivable. So, that's good. Remember, the key to life is lowered expectations. We need to sort out a solution for the anti-sway bar next, and that's likely to raise some questions, but I think it's best to leave it for next time, so stay tuned. If you enjoy what we're up to, please help us out by subscribing and sharing this series with some friends. A huge thank you as always to our awesome patrons and PayPal donators for their support, as it really means a lot. If you'd like to help and see the next video a day early, please check out the link on the screen now, and we'll catch you next time.